Welcome! Today we're going to salvage some batteries, test them, and build our own custom battery pack, specifically the 18650 cell. Well, why do we want to build our own battery pack? We could just buy a pre-made pack like this. Well, it is pretty expensive, and if we can find unused batteries from laptops or from portable battery packs, we can find new life for them. Or if you need a specific battery size. For us, we are building a VR backpack, which is coming up next week, so stay tuned for that. Before we move on, let me go over some battery basics to get you started. Of course, there are different battery sizes other than the 18650. This one is a 26500. The voltage is the same, but the capacity is different. So the size of the battery packs depends on the voltage and the amp. What you want to power determines the voltage of your battery pack. A phone, Arduino, Raspberry Pi, 3 volt to 5 volts. Small appliances, 12 volts. Electric bike can go 36 volts to 72 volts. The amp asks us how much current does our device draw and how long do we want to power it for. To get the voltage we're looking for, we can arrange them in series. To get the amperage, we can rearrange them in parallel. Here, we're dividing the voltage to double the amp. A common notation you often see is some battery in series and some battery in parallel. This one is 1 in series and 2 in parallel. You can add more. This one is 3S, 2P, 3 in series and 2 in parallel. This is common in laptop batteries. This will give you, well, let's see, 3.7 volt and 7.4 watt hour. Some battery has the specs or the model number labeled on them. If the specs is not on there, we can always look up the model number. If we take 3.7 volt times 3 in series, we get 11.1 volt. If our devices need 11.1 volt, then this would be perfect. This one actually has the watt hour label on it, 7.4 watt hour. If we take 7.4 watt hour and divide by the voltage, 3.7 volt, we get about 2 amp hour. So this gives us 4 amp hour total. One other important value to pay attention to is the C rating. It is the rate at which you can discharge battery relative to the battery capacity. This one is a really crappy battery. It is 2000 milliamp at 1 C, which means I can maximum discharge at 2000 milliamp. I don't want to discharge over than that. It will overheat and damage the battery. If I want to discharge more than that, I want to parallel another battery. But say if it is 2C, I can discharge 4000 milliamp. Of course, it will deplete twice as fast. All right, we got a whole box of these portable batteries to go through. And tons of these electric bike batteries. They were thrown away by a bicycle rental shop. So we'll go through this another day. So laptops or portable battery pack can be pretty difficult to crack open. Just be careful not to puncture the battery. It can cause the battery to vent and catch on fire, right? I found the easiest way for me is to go through the power button. So I'm going right underneath and avoid any direct hit. Now I do want to stress on lithium battery safety. Inspect the battery for any defects like swelling. Use the right type of charger. Don't overcharge or over discharge. Charge and store in a safe place.
Do you have the fire extinguisher? Fire extinguisher. Oh shoot, I got scared. Oops.
Oh god.
I got. Sorry.
This is the money shot.
Oh man.
That's right.
We have to do another one so I can smoke.
No, sorry. Natural instinct. I just took it with me.
And of course, don't do this. As you can see, there's a huge amount of energy that gets released. There you go. Alright, that's one. We'll go through all the batteries, check the voltage. If it's 0 volt, is dead, we'll chuck them away. Next, we'll charge them to full and then discharge them to get the capacity. And the reason we want to get their individual capacity is because we want to group them with similar size. Once we weld them together, the whole pack charging and discharging is only as good as the smallest cell. You can get one of these charger. This one charge individual cells, but for this pack you can just get a placeholder cell and then connect the terminal. This is a 1S discharge 1.5 amp. And generally people have some sort of BMS, a board that can protect over discharge, overcharge, and also balance the cell. I will use this fancy battery monitoring system instead. For my application, it will trigger an alarm if the battery is below a certain voltage, which give me a chance to swap battery. The BMS, on the other hand, will shut down. For charging, with the BMS, you need to charge through the BMS. You need to get the right charger for the voltage of your battery pack, and also it needs to be a charger, right? Not a power supply. To charge without the BMS, we can use one of these chargers along with a cell balancing cable. But even with BMS, I recommend just exposing these cell balancing terminals on the battery pack so we can use some of these common chargers. And the way these balancing cable are connected is the red cable goes to the positive terminal and each of the black cables go to the negative terminals. This way the charger can get the voltage of all the cells. For example, it can get the sum of the voltage of these two cells minus the voltage of this cell to get the cell in the middle. Next step, we'll weld these packs together. Now, you can get one of these spot welding machine, but they are pretty pricey. This one is $200. If you have a lot of packs to build, I do recommend getting one. It does make the process faster. This portable welder does make it easier to work with, but it is a bit underpowered. The other option is soldering. You can solder these cells together, just remember to turn up the temperature and use flux for better adhesion. I'm targeting a device that consumes 350 watts and I'm looking to power it for 1 hour. Since these cells are already welded together in 5s, I'm going to weld another sets together to get us to 10 in parallels, which is 20 amp hour. Then I'll weld 5 of these together in series to get us to 18.5 volts nominal, which put it in the range between 16 to 24 volts that my device will take. Now that they're welded, we can solder on the balancing connector. And note the order of the wires. We should start at the negative terminal and work our way toward the red wire. Alright, next we're going to prepare our terminal connector. We do want to make sure our wire gauge is thick enough to support our battery pack. This one I'm using is a 14 gauge for a 15 to 20 amp power draw. I really love XC60 connector. They're easy to make and super satisfying to connect and disconnect. Here, I'm just going to weld an extra nickel strip on top of the terminal to make sure we have a strong connection. These nickel strips do have an amp rating. You want to make sure that you have enough to support your power draw. Okay, so now we're ready to drop it into our battery box. This one is 3D printed. We just want to protect it from punctures and make it easier to handle in general. You don't have to print one. You can buy something like a junction box. You could put it in a box like this. This one is specifically for marine use. Okay, now we can seal it up. Finally, let's charge the pack to 100%. We want to make sure we select the right chemistry, which is lithium-ion. And the charging current, we can go all the way to 20 amp, but we're in no rush, so we'll just do 5 amp. For this pack, it will take about 3 to 4 hours to charge from 0 to 100% for a 400 watt hour battery pack. Notice the third cell voltage is below the rest. The charger will slowly bring that cell up to match the rest of the cells. Alright, that's it. I hope I covered enough to get you started. We have an upcoming VR backpack video using this battery, so stay tuned for that. And thank you for watching.